So what is a quadratic equation? So before you answer this, think of quadratic polynomial. What is a quadratic polynomial? As we know, there are many types of polynomials, and one of them is quadratic. Quadratic means degree 2, all right? A polynomial, ax squared plus bx plus c. So this is a polynomial of degree 2. Now, where a, b, c are any real number and a should not be 0. So we define a quadratic polynomial. And then what is a quadratic equation? Whenever we equate this quadratic polynomial with some number, it has become a quadratic equation. Formally define quadratic equation. A quadratic equation in the variable x is an equation of the form ax squared plus bx plus c is equal to 0, where a, b, c are real numbers and a should not be 0. Why do we say a should not be 0? Because, see, if a equal to 0, let's see what happens. If a is 0, then 0 into x squared, the first term becomes 0, and our expression gets reduced to bx plus c is equal to 0. So this is, of course, a linear equation. The highest degree of any term in this expression is 1. So this is what? This is a linear equation, no longer a quadratic equation. However, if b is 0 or c is 0, our equation will still be a quadratic equation. So that's why we are saying, we are mentioning only one thing, that a should not be 0, and b and c means b and c can be 0. All right, standard form of quadratic equation. Now, what is the standard form of quadratic equation? See, sometimes the quadratic equation, the terms are written here and there in jumbled manner. So we would like to organize it and write the expression in descending order of their degrees. The terms of expression should be written, here we are. Write the terms of the expression in descending order of their degrees. Then it becomes a standard form of quadratic equation. Means the form we wrote was already in standard form, ax squared plus bx plus c equal to 0. So this is a standard form. Only care that we only thing that we should keep in mind, that this order should be decreasing order of degree of the variable. Now our quadratic equation variable, we can take anything, like the variable can be y, then the expression can become py squared plus qy plus r equal to 0. Again, here also p, q, r are some real numbers and p should not be 0. Or we can also write our expression, if we make the variable t, our expression or our quadratic equation would become at squared plus bt plus c equal to 0. So variable can be any, represented by any other alphabet, and ABC would be constant. So that is a simple definition of quadratic equation. And also the standard form means nothing but we write the terms in decreasing order of their degrees. Find the solution of quadratic equation. What does it mean to find solution of quadratic equation? Solution of quadratic equation means you would like to find the value of x which satisfies the given equation. Satisfies the given equation means when you substitute that value of x, your left hand side becomes is equal to right hand side for certain value of x. That value is the solution of this quadratic equation. One more thing is to remember, whenever you solve, and you'll find in many, almost every time, that the maximum number of solution a quadratic equation can have is 2. The degree is 2, maximum number of solution is also 2. All right. So there can be no solution. There can be a case when we have no solution of the equation. There can be cases when we have only one solution. When we have only one solution, we also call them repeated solution, means both, because we should have two values, no, means both values of x are just one number. That can suppose x is 1, so just one root, and another value is x is also 1. We will see it in detail when we solve the equations, but right now I want to sum up that the maximum number of solution of quadratic equation is 2. All right, and when we have to solve this, we said we can do it by simply taking randomly by hit and trial method. We can substitute value of x and then figure out what is the solution. But of course, there being infinitely many real number, it's a very, very lengthy process and not advisable either. So what do? We instead factorize this expression, change this into linear factors, and then find the solution. So let's see this question. So let's write it once again. 2x squared minus 5x plus 2 is equal to 0. Splitting middle term that we had learned in class 8, we would like to revise it. Multiplying, we want the product of the first number and the third number. What is the product of the first and third here? 2x squared into 2, 4x squared. So we want to get two numbers whose product is 4x squared and whose sum is minus 5x. Sum is here minus 5x. So what are those two numbers? To do it, what will we do? We will just take the number 4 because we wanted 4x squared and we will factorize it. How do you factorize 4? Prime factorization of 4. So 2, 2, again 2, 1, right? You see the factors are 2 and 2, 2 and 1. So we can rearrange it, like we can take this and this because we want -5. So our expression can be written as 2x squared minus of 4x minus of x plus 2 equal to 0. Now adding, we get -5, and multiplying, of course, we'll get 4x squared. Positive, negative into negative is positive. Now you take 2x common, and what is left from here? X minus 2. And from these two terms, we take -1 common and x minus 2 again. That is 0. So this will give you x minus 2 and 2x minus 1 is equal to 0. So it gives x minus 2 equal to 0. When we further solve it, we get x minus 2 equal to 0, and see, when the product of the two terms is 0, that means either both are 0 or at least one of them is 0, right? So we are equating them separately. X minus 2 is equal to 0 or 2x minus 1 equal to 0. So this will give you 2x is equal to 1, and the other one from here, we get x is equal to 2. So finally, we can write our answer. We are getting two solutions of this quadratic equation, x equal to 2 and x equal to 1 by 2. Now, we can actually check also by substituting these values in this expression, it should satisfy. I mean, left hand side and right hand side should be equal. As we see, right hand side is already 0. So if we substitute x is equal to 2 in this equation, what we get? 2 into 2 squared minus 5 into 2 plus 2. 2 squared would be 4. Minus 5 into 2 is 10 plus 2. All right, so this is 8 minus 10 plus 2. That means how much? Positive, positive added, 10 minus 10, which is 0. Yes, so this is satisfying. Similarly, we can, by substituting x is equal to 1 by 2, simply substitute x is equal to 1 by 2, and you'll find that 1 by 2 is also satisfying the equation. So these are the solution. So this part here is not necessary. This is only to check that your answer is right. You can check for yourself. All right. So here we have done it already. So the zeros see, the zeros are the roots or the solution, right? Zeros of the polynomial or roots of the equation or the solution of the equation has the same meaning. All right. So here we can see here the next one. Yes, solution of quadratic equation means the zeros of the quadratic polynomial, or it also means sometimes roots of the quadratic equation. So they can ask the same question in three ways. That means they are simply asking the same thing. They're asking you to solve the quadratic equation. So the solution are also known as roots or zeros. All right. So having done this, let us take some examples now, some questions. Here we are asked to check whether the following is a quadratic equation. So we already know the quadratic equation, and this is given in jumbled form. You see here and there terms are written. So let's try to answer the first one. When we answer the first one, it's x minus 2 whole square. X minus 2 whole square plus 1 is equal to 2x minus 3. What we need to do is we need to write this in standard form. Now you see here, this can be a minus b whole square, which is a square minus 2ab, 2 into x into 2, and plus 2 square minus plus 1 is equal to 2x minus 3. Now this would be x square minus 4x plus 4 plus 1. Now we want to write it in a standard form, which can be written as x squared minus 6x. This 2x goes to left, negative x. Now plus 5 and plus 3. This is plus 5 and plus 3, which is 8, is equal to 0. And obviously, this is a quadratic equation. So they're asking check whether the following are quadratic equation or not. The first one is a quadratic equation. Let's see the second one. We can simply open the bracket for the second one, right? So x into x is x squared plus x. Now plus 8 is equal to x. See, this is a formula also, a plus b, a minus b, which is equal to a squared minus b squared. B is 2, right? 4. And we can see easily this x squared and x squared gets cancelled. Obviously, this is not a quadratic equation. You see there? What are we left with? X plus 12 equal to 0, which is a linear equation, so not a quadratic equation. All right. So the second one is not. First one is a quadratic equation. Let us check the third one now. Simply open the bracket. 2 into x is 2x squared plus 3 into x is 3x is equal to x squared plus 1. Now we'll take every term. We'll write this in standard form, no? So 2x squared, this goes left, minus x squared. So 2x squared minus x squared, only x squared is left, plus 3x, and this 1 can be taken to left. So obviously this is a quadratic equation. So the third one is also a quadratic equation. Let's see the last one, the fourth one. So the fourth one is x plus 2 whole cube. This is the fourth one. X plus 2 whole cube is equal to x cube minus 4. To solve this, you must be remembering the formula a plus b whole cube. If not, you should write it right here. The formula for a plus b whole cube is a cube plus b cube plus 3a square b plus 3ab square. All right, a cube plus b cube plus 3ab, and in the bracket you write a plus b. When you expand, you get something like this. So we'll apply it here. So this will imply our left hand side become a cube, which is x cube, plus b cube means cube of 2, right? Let me write it, b cube, right? And plus 3 times x a square is x square and b is 2, all right? And plus 3 times a is x and b is 2, so square of b is equal to x cube minus 4. As we see, this x cube and x cube gets cancelled, and we get 2 cube is 8 and plus 6x squared, and plus 3 into square of 2 is 4, right? 4 3 is 12. 12x is equal to negative 4, and this means 6x squared plus 12x plus 12 is equal to 0, obviously a quadratic equation. All right, so we have done these all four parts. The first one is, second one is not, third one is, and fourth one is not. So we can write, therefore it is a quadratic equation. We can conclude in the end in every part. Therefore the fourth one, it is a quadratic equation. All right, fine. So sometime we are given equation in jumbled form here and there in whichever way they want, and they will ask whether this is a quadratic equation or not. When you practice more and more question of this type, you can simply look at the question and can answer it. But at the initial stage, it makes sense to actually write the equation, expand the terms, simplify them, write them in standard form, and then say whether it is a quadratic or not. Because when you practice it like this, you will get more and more used to, your speed will increase. There are many benefits of this, right? At the second stage, you can just look at the question and say, yeah, this is not. So you become more and more used to these things. All right. So next we'll move on to the second question. They're asking one more question here. They said, find the root of quadratic equation this. So they will ask like this. Sometimes they'll ask find the root. Sometimes they'll ask you solve the equations. Sometimes they'll ask find the zeros. It has the same meaning that you simply have to factorize this expression, right? Similar to the first one we solved. So here also, what we will do first of all, we will take the first term and we will take the last term, multiply them. Both are positive, 2x squared into 3. How much will you get? 2x squared into 3 would be 6x squared. Multiplying, you want 6x squared. And adding, you want negative 5. All right. So what we can do is simply take the factor 6. Okay. Take prime factor of 6. So divisible by 2, 3 times, divisible by 3, 1 time. So the factors are 2, 3, and 1. Now see, how can you arrange these factors taking 2 or more one time and the rest other time? I mean, in one group, another group, and seeing that, can you get two pairs where when you add, you get negative 5 and multiply, you'll obviously get 6 because you are getting the factors of the 6 only, right? So here, 2x squared minus 5x plus 3. So the numbers can be negative, see, negative 2, negative 3 will do it. How? 2 and 3, sum would be 5. And 2 into 3 will give you 6. So our expression, first let's write the quadratic equation. Once we figure out the factors are 2 and 3, means we have to split our middle term by 2 and 3. We can write our expression, which is 2x squared minus 5x plus 3 equal to 0. And now split the middle term. This implies 2x squared minus 2x minus 5x plus 3 is equal to 0. So this will imply you can take 2x common, and then you have x minus 1. Is something common here? Oh my god, 2x minus this is 3x, right? Display, we have made the part 2 and 3, because minus 5 can be written as minus 2 minus 3. Then minus 3 common, and x minus 1 again is equal to 0. So this will imply x minus 1, 2x minus 3. Again, we have got two linear factors, and their product is 0. That means either any one of these two factors, or both are 0. So we can say this implies either x minus 1 equal to 0, or 2x minus 3 equal to 0. What does that mean? It means if we take x minus 1 is 0, so x is equal to 1, or 2x is equal to 3. Simply transpose this 3 to the right. This gives you x is equal to 3 by 2. So we are getting two values of x, or we getting two roots of this quadratic equation. We can sum up x is equal to 1, or x is equal to 3 over 2. That is your answer. All right. So we can find the roots of quadratic equation like this. Simply factorize into the linear factors if they can be factorized. Then equate the linear factor to 0 to get roots. All right. So let's take one more question. Here it is. Find the roots of the quadratic equation. So let's write this quadratic equation first. The quadratic equation is 3x squared minus 2 square root of 6x and plus 2. Something like this is equal to 0. So we have to find roots, so we'll equate this equal to 0. So 3x squared plus 2 root 6x plus 2. Now, when we do the same comparison to this expression, we want to find the product of the first and the last. Product of 3x squared and 2 would be 6x squared. That means adding you want so multiplying we want 6x squared. All right. So we'll simply do the prime factorization of 6, 2, 3, 3, 1. So the factors are 2 and 3. How can we factorize so that adding we get 2 root 6? If I take 2 and 3, product is 6, fine, but multiplying we are not getting, adding we are not getting 2 root 6. So there is only one way. So we'll have to think little irrational numbers about, like our 6 can be written as root 6 plus root 6. I mean, 2 square root 6 can be written as square root 6 plus square root 6. It's like two mangoes, one mango plus another mango. All right. Now that's what we'll do here. So let's write this 3x squared as it is, minus square root 6 of x, one more square root 6 of x plus 2 is equal to 0. Now, again, we would like to see what is the common factor there. As we observe, 3 can be written as square root of 3 into square root of 3. In the same manner, 2 can be written as square root of 2 into square root of 2. All right. Now this expression becomes, in these two terms, when we know this, we can easily see that there is something common in these two terms. And also the square root 6 can be written as square root of 2 into square root of 3. Okay, square root of 2 into square root of 3. Now we'll apply these things here. And we observe that square root of 3x is common in first two terms. And then we get x minus square root of 2. And in these two terms, we get minus of square root of 2 common, and we get, it is, I think it should be square root 3 here, no? Square root 3x. Let us write it again. So when we take a square root 3x common, we'll have square root of 3x and minus square root of 2. From here also we take a square. Now square root 2 is taken common. Here we will be left with square root of 3x minus square root of 3x minus square root of 2 is equal to 0. Now we see this term square root of 3x minus square root of 2 is common. So we take it common like this. And from the first, we get square root 3x minus, here we have square root 2. So we're getting the same factor here. Either this is 0 or that is 0. What does this mean? Now, we can write as either square root 3x minus square root 2 is 0, or the same thing as 0. This factor is 0, right? Square root of 3x minus square root of 2 equal to 0. So that gives you square root 3x is equal to square root 2, or x is equal to square root of 2 divided by square root of 3. So from the both parts, from the first part as well as second part, since the factors are same, you are going to get the same answer. So in this case, you have repeated root and both the values of x, as we say, the maximum two values are possible. So we are getting repeated root, we are getting same number twice. It means we have just one root. Okay, in other terms, we can say this quadratic equation has just one root. And what is that value of x which is satisfying this equation? That's what we call root, no? So x is equal to square root of 2 by 3. So when you put x equal to square root of 2 by 3 in this quadratic equation, your left hand side and right hand side should be equal. All right.